All right, continuing on, question 7. Solve the system of equations graphically. All right. So again, I've given you a graph. We want y equals x minus 3 on the graph. So again, we have an m that's equal to 1. We have a b that's equal to negative 3. We want to find our b on the graph. And we want to increase by 1. We want to move to the right by 1. So we're going up 1 over 1, up 1 over 1, up 1 over 1. Takes 2 points to make a graph. And so we have graphed our first line. Now let's graph our second line. Y is equal to 3 over 2x. So we have an m of 3 over 2. We have a b of 0. There's nothing over to the right of the 3 halves x, which means this equation is going through our order pair 0, 0. It is going up 1, 2, 3 over 1, 2. It's going up 3 over 2. It's going up 3 over 2. Now, the further we go up, it seems like we're getting further away from the line. Well, that's what's happening. So we're going to have to go down to find our solution. Down 3, back 2. Down 3, back 2. Down 3, back 2. All right, I see a spot where I've intersected. Let's go ahead and connect our dots. And so our solution appears to be right down here. I know it's hard to see all these numbers on the graph, especially in the camera, but that's okay. You can count them. We have 1, 2, 3, 4, 5, 6. We come down to 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 6, negative 9. Now, if you need to, you can check your solutions in the equations. X is negative 6, so negative 6 minus 3 does give you negative 9. All right. Yes, I realize you can't see the entire question, but I don't want to get it so far zoomed out to where my writing is looking small and my hand is looking like it's taking up most of the page. So I'm going to give you that much, and you can look at your worksheet to see the rest of the question. Raymond sells cars and trucks. He has room on his lot for 510 vehicles. From experience, he knows that the profits will be greatest if he has 190 more cars than he has trucks. How many of each vehicle should he have? So he has a certain number of cars and a certain number of trucks, and together, let's make that a capital T so it doesn't look like a plus sign. Together, he has 510 vehicles. Now, if he has 190 more cars than trucks, he's in good shape. So we want to take the trucks plus 190. That's how many cars he wants to have. This looks like a great equation for substitution because we already have a variable isolated. So we're going to take that and plug it in. T plus 190 plus T is equal to 510. Now I don't need the value in the parentheses because there's not a negative sign in front of it. So T plus 190 plus T is equal to 510. Combine like terms, 2t plus 190 is equal to 510. And now's where we're going to start dealing with solving the equation. 510 minus 190. 2t is equal to 320. Where we divide by t and we determine that t is equal to 160. Well, since t represents the number of trucks that we should have, and we have 510 total vehicles, well, we can take our original equation. C plus T is equal to 510. We have a certain number of cars, plus we now know we have 160 trucks, equals 510. So we subtract 160 from both sides, and C is equal to 350 cars. Now, at this point, we can make sure that it makes sense with our second statement. We need to have 190 cars more than trucks. If I have 350 cars and I subtract 160 trucks, I have 190 more cars. So we have satisfied the statement. How many of each vehicle should we have? I just need to write my solution. I should have 160 trucks and 350 cars. All right, Shirley is 21 years older than Laura. Remember, is represents equals. Shirley equals 21 years older than Laura, so Laura plus 21. In 6 years, so if I add 6 years to Shirley, will be is another form of is, so equals twice as old as Laura. Now, just by replacing the words with numeric symbols, we can see that I've got two equations here. One of my equations, S equals L plus 21. Another equation, S plus 6 equals 2L. Now, it looks to me like another great substitution problem, so we're going to substitute in the value of S. So, L plus 21 plus 6 is equal to 2L. All right, let's clean this up a little bit. I don't need the parentheses. I'm going to two-step just a little bit here. 21 plus 6 is 27, so L plus 27 is equal to 2L. Subtract L from both sides, and 27 is equal to L. So we have learned that Laura is 27 years old. Now, how old is Shirley? Shirley is equal to Laura's age, which is 27, plus 21. We pulled that from our first equation. 27 and 21 gives me 7 and 1, which is 8. 2 and 2 is 4. So Shirley is equal to 48 years old. Let's write our final solution. Laura is 27. Shirley is 48. Next question. Tommy missed school. When the class solved the equation 2x minus 3 over 5 is equal to 4x minus 2, write an algebraic proof for the solution. Well, if we want an algebraic proof, that means we're dealing with a two-column proof where we need to have a reason. Now, hopefully, we have all recalled that our very first step is to rewrite what is given. So 2x minus 3 over 5 is equal to, I'm going to have to fit this in, 4x minus 2. And that is always by justification that it is given information. Now, when we're solving proofs, it's not so important that you show all of the work for each step, but that you show the conclusion for each step. So we want to ask ourselves, what do I need to do to clean this problem up a bit? We're going to multiply both sides of the equation by 5. Well, if I multiply the left side of the equation by 5, I end up with 2x minus 3. If I multiply the right side of the equation by 5, let's go ahead and just say 5 times 4x minus 2. That's going to be our multiplication property of equality. All right. Well, we would know that I have parentheses we need to distribute. So 2x minus 3 is equal to 5 times 4 is 20x minus 5 times 2 is 10. How did we get there? We distributed. So distribution property. All right, what's next? We need to get x's on one side of the equation. So let's subtract 2x from this side. Now, since we don't have to show our work, I'm going to do it on here just so you can see what's happening. We can actually go ahead and do addition and subtraction at the same time. So I'm going to add 10 and add 10. This will clean things up really fast. So step 4 is going to leave us with 2x minus 2x gives me 0x. Negative 3 plus 10 gives me 7 equals 20x minus 2x is 18x. Negative 10 plus 10 is 0. Now our rule for how we got there, addition, property of equality. Now, yes, we did subtract, but remember, subtraction is the inverse of addition. And so if I'm thinking about, hey, I subtracted, another way of saying that is I added negative 2. So if you want to say add, subtract, property of equality, that's fine. If you're fine with recognizing you're adding an opposite, that's fine also. Now, in order to get x by itself, we divide. So step 5, 7 over 18 is equal to x. So step 5 would be the division, property of equality. And then ideally we want to see x on the left side. I've run out of room, so let's continue over here. X is equal to 7 over 18. That's going to be your symmetric property of equality. All right, last problem for this page. Badger Rent-A-Car Company compact cars. Badger Rent-A-Car rents compact cars at a daily rate of $23.95 plus 20 cents per mile. I'm pretty sure we could write that as an equation, right? My daily rate is equal to 20 cents per mile, 0.20x plus $23.95. Cactus Rent-A-Car rents compact cars at a daily rate of $22.95 plus 22 cents per mile. So our second rental company, 0.22 cents per mile plus $22.95. At what mileage is the cost the same? Now you've got a couple of different options for solving this. You could certainly put them in a standard form and use elimination. I like to use substitution on these type of problems because notice we have isolated the y in both equations. So my isolated y value is simply going to plug in up there. This makes for a fairly clean problem because 0.22x plus 22.95 is going to now be equal to 0.20x plus 23.95. And so we want to get x's on one side, so we'll subtract 0.20 from 0.22. And we end up with a 0.02x plus 22.95 is equal to 23.95. where I will subtract 22.95 from both sides. All right. So 1 is equal to 0.02x. Now we're going to divide by 0.02, and x is equal to 50. Now we just have to remember what x represents. X was our variable for per mile. So x was our number of miles. At what mileage is the cost the same? When x is 50, the cost will be the same. So at 50 miles. Good job.